Hello.
Hello.
So let's two more people go join, then we can begin. I think it's 10 minutes already. So yeah. See. Yeah. I it's already 10 minutes, so I think we can start. They already know that they should join after 10 minutes. So they will join us as we proceed. Now, we look at example we are solving. Remember, we did part A and part B. Remember that the question is to find the confidence interval for the mean. So it's a sample of reading scores of 35 fifth graders has a mean of 82. The standard deviation of the population is 15. Find the best point estimate for the mean. We answered that already. Just B said find 95% confidence interval for the mean reading scores of all fifth graders. We answered it here. That was what the last one we answered before we were timed out. Then let's go part C. Part C said find the 99% confidence interval, the mean reading scores of all fifth graders at part C. So it's still the same method, except that now this time around, our critical value will be different. So because our numbers is still, sample size is still 35, mean is 82, standard deviation is 15. So I'm going to copy this and paste it down here because it's still the same thing. So now what we've done different is critical value. Now, this time around, we're finding the 99% confidence interval. So I will use the critical value for 99%, which, according to what our calculation was before we did at the beginning of the other session, is 2.58 for 99%. So we're going to put 2.58 here. 2.58. Next thing is to find the error margin. So our error margin is now, we use the same formula for error margin, if you remember, this one here, except that we're going to change the critical value z alpha over 2 to 2.58. Okay. So I'll take you to that workbook where we can change it to 2.58. Okay. Now we have, excuse me. So we have it here. Okay. Give 1 minute. Okay, I think this is right here. Now, taking you there, we have, what is it, right here. So we're going to use 2.58 here instead of 1.96. This time around, we're looking for 99%. So let me write this down, and then we can put this in our calculator, get the answer. For the error margin, we got 2.58 times 15 over square root of 35. So to give us a different one. That's the only that will change. And then we can get our error from there. So we got 2.58 times standard deviation of 15 divided by square root of 35. Okay. All right. Get 6.54. Get 6.54. So we go and put it in our formula. 6.54. And then we copy the whole thing into our main workbook and round up. Okay. I'll have it as, where are we? Okay, right here, 6.54. This is for 99%. So we can see that the 99% confidence interval is this. So I'm gonna to make it faster, I'm gonna put this here and change it. This is 99% is given by this formula, and that means 82 minus what we have is 6.54. You subtract it on the left side. On the right side, you add it. 6.54. Okay. And that will give you the confidence interval. So you have 82 minus 6.54. Let's go and do it. 82 minus 6.54 is 75.46. 75.46. That's 75.46. Okay, it's less than the mean. So I'm going to copy it from here. Okay, less than the mean. Less than, then on the right side, you add it. Right side, you add it. Here was I. Here, instead of minus, add it. 88.54. 88.54. 88.54. Okay. So now we can conclude now. Conclusion. Okay. We are 99% are confident that, okay, the mean or average mean, excuse me, okay, that the mean, which is the mean score, mean reading scores of all fifth graders, so it means reading scores of all fifth graders, okay, lies between 75.4346 to 88.54. See, so when we use the 95%, it was 77.03 to 86.97. When we use 95% confidence, it is 75.46 to 88.54. So that's how to do confidence interval for the mean. Any question on this? Yeah. Good. Now, sometimes they might ask you the question in a different form. They might give you the raw data, like here. They say, find a random sample of number of farms in thousands in various states as follows. They give you this. 47 farms, actually 47,000 farms, 95,000 farms, and so on. And a random sample of number of farms in various states as given. So estimate the mean number of farms per state with 90% confidence. So to make this thing faster, as a matter of fact, one of your, I think your Excel assignment 5, I believe, you have a question like this on that, that. So what we're going to do is to put them in Excel, or let me put it this way. They didn't give you the mean, so you have to calculate the mean by yourself, calculate the standard deviation by yourself, and then use it to do the same thing I just did in the other example. So to make it faster, Excel might help. Otherwise, you can use the same formula for calculating the mean that I taught you at the beginning of this class. You can use that as well, but that will take you time. So Excel will make it easier. So I put this in Excel. I'm going to use Excel to get the mean. So using the Excel, I will say that, okay, using Excel, okay, Excel, okay, to calculate the mean. we have that. Now, I'm going to put mean and standard deviation, which we don't know. So let's see. X bar and then standard deviation and the sample size. Let me put them in here. Sample size, how many of them do we have here? How many do we have? That 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So our N is 31. 31 states. Standard deviation, we don't know. We have to calculate it using then this mean, we're going to get it from using Excel. Okay. We're going to mean then we need to get the error margin. Since we're going to use Excel, we are not going to worry about Z alpha over 2 now. We put it in Excel. So what we need is the error margin E. Error. Error. Margin E equal. Now we get this in Excel too. Excel will make all this faster. Okay. All right, to have it faster. Now let's put these numbers in Excel. The good news is that I've already have them in Excel. I have them here. So you see, content interval of farms. I hope you can see my screen. Yes, I think you can see it. Since I have them in Excel, what I'm gonna do is to highlight them from here to the last number. Okay. All right, see, I think I have the list here as well. Make sure I have the correct list. Okay. It's right here. Okay. Yeah, it's right here. Anyway, you can see my Excel, right? Right or wrong? Hello? Can you see my screen?
Yes, we can see it.
So you highlight it. So now, what you're gonna do is just click on data. Okay, data analysis. So you click on data, then go to data analysis. Click on that, and then choose I'll use descriptive statistics. Would that be? Let me see if that would be better to use. I think that's what you're gonna use. Descriptive statistics, that would be better. That'll give us yeah, it will give us the what we need. Okay. Now once we click OK, it will bring up this dialog box. Let me repeat it again so you can see what I'm doing. First of all, you click on data. Of course, first of all, you enter your numbers in the Excel. Then click on data. Then data analysis. Choose descriptive statistics. Click OK. Now you can now choose numbers by clicking here. Call it in the input range. Click here and click on the first number. Highlight all of them all the way to the last number. Okay. Now we have them. Okay, have it here. Then it was grouped by columns. Okay, good. There's no need to label. For the output range means where the place you want your result to show. You click the output range. Okay, click here. I want it to be placed here. So I'm gonna place here. Okay. And this is, if you remember, this is 90% confidence interval. I'm going to choose summary statistics. Then for the confidence interval, I'm going to choose 90%, change this to 90%. Okay. What else? I think we're good. Simply click OK. See, it gave us everything. It gave us the mean 43.5 43.45. So our mean is 43.45. Let me go where we can get the character for the mean. Mean is X bar. Sample mean is 43.45. So I'm gonna copy this and put it in our main workbook. Okay. 43.45. See, I'm gonna put it right here. And the standard deviation is here. If you look at our result, our output, what is it again? I think it's right here. You can see the standard deviation right here, 31.27. 31.27. 31.27 is standard deviation. Actually, you don't even need this. Since you're using Excel, you don't need this. All you need is the mean. Okay. Because Excel gave you the error margin already. So look at the error margin right here in Excel. I will show you where the error is. The error is right here. See why they have the confidence level of 90. See, that's the error margin right there. So you don't have to calculate the error margin anymore. Excel give it to you. Approximately 9.53. Error is 9.53 approximately. 9.53. 9.53. So that your 90% confidence interval becomes S bar minus error, less than the mean, less than S bar plus error. Okay. So let me copy where we wrote the formula already. So you can just change the numbers, make it faster for us. Okay. So I'm gonna paste it here, remove the other numbers there, and put hours. Okay. Save a lot of time for us. Okay. So we got our mean is 43.35. 43.35 less than the mean. This is the mean we are trying to estimate, the population mean we are trying to estimate. We don't know what it is. Only Providence knows. We are trying to get an estimate that is as close as possible to that. Okay. Minus error. Our error is minus error. Our error is 9.53. Then on this side, we add it. The same thing, but we add it. Sort of subtraction, we add it. So on the left side, you subtract the error. On the right side, you add the error. See? Okay, plus the error. So I'm gonna copy it from here and put it here. So you know what? I'm gonna move this down. Oh, consume the whole page. All right, see? So this is it right here. Now, from the calculator, we can get this 43.35. Let me write this down. 43.35 minus 9.53. Okay. I'll take you to the calculator. We got 43.35 minus 9.53. It was 33.82. 33.82 on the left side. Okay, left side is 33.82. Okay, 33.82. Oh, sorry, 82. Less than the mean, less than on this side. Just change it to plus. That will give us the upper side. Change it to plus. 52.88. We got 52.88. 52.88. So now, so we are given this list of numbers. In this case, since we have a raw data, we can use Excel to simplify it. And this is our answer. This is our confidence interval between 33.82 to 52.88. And remember that this is about a random sample of number of farms in the state. So we were asked to estimate the mean number of farms per state with 90% confidence. So we can say we can say with 90% confidence that each state have on average between 33.82 82 to 82.88 farms. Okay. To 33.82 to 52.88 farms based on a sample of at one farm at one state. Any question on this? Any question?
No, sir.
No question. Good. 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 Now, we can now look at how to estimate the minimum samples. If you have a question, please ask. I don't respond to text messages. This is a class where we are free to ask questions. So now, sample size computations. To compute the minimum sample size you need, this is the formula you're going to use. N equals to Z alpha over 2 times standard deviation of the error. Let's see how this works. It says it is desired to estimate the mean number of chocolate chips per cookie for a large national brand. How many cookies will have to be sampled to estimate the true mean of number of chips per cookie within 2 chips with 98% confidence? Assume that the standard deviation is 10.1 chips. Okay, so what you need to know is to list the values for the critical value, for the standard deviation, and for the error, and plug them into this formula, and then you get the answer. In this case, you say with 98% confidence. For 8%, we are not giving it in the table here, but we can if you don't have it on the table, we can estimate it. See, 98% we don't have it here. We can estimate it using this formula here, P over 200. So let us find the critical value first of all. Here this is the formula we need to get it. But before then, we are told that the standard deviation is 10.1 chips. Okay, 10.1 chips, and that's they want to make how many cookies have to be sampled to estimate the true mean of chips within 2 chips. Now, within 2 chips means that their error, if they're going to make a mistake, it's going to affect only 2 chips. So their error margin is 2. Error E equals 2 chips. Now, what is left now is to estimate the critical value for 98%. So for that, we're going to use P over 200. That means, let me take you to where we can get the formula, the formula results in another workbook. We have it here. Have this P over 200. So equals, which is P is 98 this time. So you have 98 over 200. That gives us on the calculator, we can have 98 over 200. Okay, 98 divided by 200. We got 0.4900. See, because the numbers in that table is 4 digits. So you're gonna make it 0.4900, which is 0.4900. So now with 4900, you can now go to the table of normal distribution. Look for 4900. We have 4901 is the closest. This is 4898. It's 4901. This is the closest. So when you follow it to the left, you see 2.3. You follow it up, 2.33. So the answer is 2.33. We've got 2.33. So I'm gonna copy this and paste it in the workbook, our main workbook, so we can get our sample size required. So I put it here. So now note that we did this because we don't have the critical value for 98. If we have it, if it's on the table, we can just pick it from there, and put it in. So now, having found that, then let's calculate the minimum sample size for this. So minimum sample size will be, the minimum sample size formula is right here. So I'm gonna put it here. Okay, minimum sample size formula. Excuse me, I put the wrong one. It's right here. Minimum sample size formula is right here. I'm gonna move this thing down so we can have enough room for this. Okay. Minimum sample size will be plugging all these numbers, standard deviation, error, and critical value. Let me write them down. Standard deviation is 10.1, error is 2, and critical value Z alpha over 2 is 2.33. So let's go and put this in the formula workbook, and the other workbook, so we can get the output. Okay, have this. So plugging these numbers, we have that n is we have this Z alpha over 2. Oh, excuse me, I made a mistake. Okay, I'm gonna put this. So Z alpha over 2, this Z alpha over 2 is 2.33. 2.33 times standard deviation of 10.1 divided by error of 2, everything squared. That will give us the sample size. So I'm gonna put this in calculator, get our results. Okay, equals 2.33 times 10.1. Okay, all right, over. Okay, I think I have to start all over. 2.33. See how we can make it over error. Error is 2. I'm trying to form the equation correctly. 2.33 times 10.1. 10.1. Okay. Close it and then square it. So 138.45. 138.45. 138.45. Okay. I'll make it more adjusted a little bit. So that means usually in this case we round up to the next whole number. So the answer will be this 138.45. So that means that because it was how many cookies have to be sampled? They need 139 samples. They need 139 samples or sample 9 or cookies. Because even in algebra, this is one. If you run this, it's gonna be 138. But we're not talking about rounding up. We're talking about rounding up. So as you have a decimal part, we want to do the next number, which is now at 9 samples. Any question on this? Any question?
I have questions, but I need to let it like marinate.
Go ahead, ask. Hello. Hello.
Yes. 1 second. Yeah, I think when you do another example, I think that I'll be able to follow.
Okay. Another example is this one, pizza store. You say that a pizza shop, want to a pizza shop owner wishes to find with the 95% confidence interval of the true mean cost of the large plains pizza. How large a sample should the sample how large should the sample be if she wishes to be accurate within 0.15 cents? That means if there's going to be an error, it's going to cost only 15 cents. A previous study showed that the standard deviation of the price was 26 cents. Okay, solution. Okay, we have our standard deviation and error given. We have our standard deviation error here. The standard deviation this time is 0.26. 0.26. And he said he wished to be accurate within 15 cents. So error is 0.15. Now, critical value Z alpha over 2. Z alpha over 2 for 95%. We have it on the table. It's right here. We have it calculated already. Z alpha over 2 for 95% is right here. Is 1.96. See, it's 1.96. Okay, so we're just gonna pick it up from here. So we have it right here, 1.96. So just pick it from here. Okay, 1.96. Okay, 1.96. So plugging it into this value, let me write these numbers down. We have delta is 0.26, error is 0.15, Z alpha over 2 is 1.96. So remember that the formula is this one here. We'll copy it and paste it here. So we can go and plug these numbers in and get our answer right away. So let me take you to that workbook. Okay, so I'm going to change all this. Okay, Z alpha over 2 is 1.96. Okay, times, can you see it? I think you can see it.
Yeah.
Okay, times, where's my times? I'm trying to see my, okay, times. I could not see the times equation. Okay, it's hidden here. Okay. All right, move this down. Okay, times. How much time do we have? 2. Okay, times standard deviation of 0.26. Okay, 0.26 divided by error of 0.15 squared. So I'm gonna go here. Okay, let me go here. And the calculator. So I'm gonna clear this. I have 1.96 over 0.15. Okay, times standard deviation of 0.26. Okay, close it. Square it. 11.54, which is 11.54. 11.54. So that'll give us round up the next whole number. Okay. Right here. So they need how many samples? They need 12 samples. Okay. Now we'll be timed out in a few minutes. Okay, this is our last session. So how do you get 12 samples? We round up to the next whole number, which is 12 samples. So if you time us out, I will see you next week in the class. Okay.
Okay.
Hello. All right.
Are you gonna upload this Zoom to the files as well?
I mean the video, yes.
Okay.
You see it in Canvas. Okay. All right.
Thank you.
You're
okay,
welcome.
thank you.
You're welcome. Yeah. Okay. Wow. All right. Any other question before